Free your mind now. Be part of People's Pan-African Parliament, the Pan-African Pyramid Debate with your speaker, Andrew Irumba Katusabe.
My name is Andrew Irumba Katusabe, your speaker. I am in Namamve Industrial Park. I have here Charles Kwesiga, Professor, Dr. Charles Kwesiga. He is Executive Director of UIRI. UIRI is Uganda Industrial Research Institute. And we are, as Africa, we talk about being practical. Now, in the world, there have been 4 revolutions. The first revolution, industrial revolutions, he will take us through. The first, the second, the third, and now we are at the 4th industrial revolution. However, we want to find out as Africa, how far can Africa or Uganda, how can they compete in the 4th industrial revolution? And Professor Kwesiga here, some of the things that we've been talking about, thinking that we are only being rhetoric, actually Professor Kwesiga has been actualizing these thoughts, and that's why we are visiting him here today to go through what he's been able to achieve since he joined this institution 2014?
2004.
2004. Professor Kwesiga, you're welcome.
Thank you very much.
So first take us through the stages of the Industrial Revolution. I know the first one began in about 1765. The second one about 1870. So let's go through that. I know you know that better than me.
The first Industrial Revolution was characterized by concerted mechanization of agriculture.
Yes.
Up to that time, the world was even involved in subsistence farming. In subsistence farming, you have one farmer who can't provide for the family all year round. In mechanized agriculture, you have one farmer who can provide for so many families. That liberated the other families to look for other vocations. And that's how industrialization started. So we started making implements, especially to support the farmer.
But also changing the tools.
And
you were using
as the industrialization process took shape, about 100 years later, they started getting more, seeking more levels of production. They started assembly line approach to production. It started mass production, spearheaded by the motor company. And another 100 years, in 1969, there was computer and automation. And today we are talking the 4th Industrial Revolution.
4th Industrial Revolution.
Which is a high level of automation, where you are talking about technologies like artificial intelligence, like robotics, like Internet of Things, blockchains, and so on. I'm happy to report that this campus where we are addressing some of those technologies.
Here?
The 4th Industrial Revolution.
In Uganda here?
Yes.
Let's go ahead.
Here in Namamve.
Namamve here.
Yes. And so this is a general campus. But in there, you see applications of the 4th Industrial Revolution technologies. We have, for example, a workshop for teaching artificial intelligence.
You are teaching AI here?
Yes.
In Uganda?
That's right.
Artificial intelligence?
Why not? You can do it. Why not? We have a demonstration of
Professor,
robotics.
wait a minute. You are teaching artificial intelligence here in Uganda?
Yes.
Are you serious?
Why not? Why wouldn't you do that?
I thought we were very far from that. We are far from that.
We are, this campus is focused on modernity in production. So we don't...
Latest tech.
Yes. But we also get into basics also. Like the main classroom building, It's mostly training people in principles of engineering, principles of machining,
Okay.
the basic building blocks that you need to make a high caliber technician and engineer. So then computer-aided design, again, this is modern technologies in use. And we shall have some prototypes of the things we have designed and built.
We're going to have a look at them.
Yes.
That's fantastic.
Okay.
That's fantastic. So let's go.
Here. Okay. I told you this is the main classroom building, but we picked up some space to look at our textile sector. Textile sector has not been doing very well in Uganda.
In Uganda.
And we are still continuing to export cotton and import textiles. They tell us how much money we pay for our cotton. They tell us how much money we have to pay for the textiles.
When you're buying.
So when you analyze the problem, you realize that the value chain for the textile is long and expensive if you try to address it all at once. However, if you take it into blocks, say start off by turning cotton into yarn, turn yarn into fabric, turn fabric into textiles, you can avoid the expensive approach of trying to address the entire value chain and make different entry points. Different entry points. As for example, in Sri Lanka, they bring somebody's fabric, they turn it into high quality textiles, and the next thing you see is textiles made in Sri Lanka in Marks and Spencer in UK, or J.C. Penney in America, and so on. Other countries opt to do just the turning of fiber into yarn. Others can focus on getting somebody's yarn and turning it into fabric. Yeah. So if you make different entry points that are affordable, eventually you will build the value chain.
Okay.
An example: if I got $16 million, I could make a viable enterprise that turns a spinning mill, but turns fiber into yarn. Yes. And so you can even temporarily stop there, sell the yarn. As you get more revenues, then you plug it back in the system, turn that yarn into fabric. And so we have 2 workshops here, laboratories actually, that test the properties of yarn, of fiber, of fabric, depending upon what.
You have them right here.
They are right.
Let's move there then. Thank you for the explanation. This is a laboratory. You call it a laboratory
for testing yarn and fiber. For example, if I'm selling cotton, what quality of cotton is it?
What quality of cotton is it?
And therefore, you can negotiate world price, knowing what quality of
cotton you have.
Here, for example, now the researchers, the textile engineers, are busy working in looking at alternative usage of other fibers beyond cotton. And so those who are into silk business, they are silk cocoons that have fed on mulberry leaves will yield silk like this. Cocoons that have fed on avocado leaves, they'll give you silk like that.
This is as a result of avocado.
And through the gumming, you can turn them into threads that eventually will make textiles. So this is work being done by my textile engineers. On the other hand, banana fibers can be turned into disposable sanitary tires. It can be turned into packaging paper. Pineapple leaf, the crown of the pineapple. Those green leaves are useful. We can turn them into the products like filters for medical applications.
So these are banana leaves?
These are from pineapple.
Pineapple?
Yes.
But
once you remove sugar cane, what you get after pulping the sugar cane, you can get the bagasse that gets out of that can be used for packaging materials and for also sanitary towels. So the sky is the limit as how much we can do with the natural resources we have. This is a laboratory for testing fabric. So we quickly we test all kinds of properties of fabric, especially for the intention of determining the proper functionality of that.
Oh, that's good.
You can just 2 seconds. That test over there for abrasion, and get through how.
Let's see how you do it, comrade. As you explain what exactly.
Now this equipment is an abrasion resistance tester. Abrasion. So you see, in normal work environment, we rub with fabrics. When you're sitting, when you're washing, when you're moving, there's always a rubbing between.
Is that friction?
Like the way the machine is doing. So this determines the number of rubs that the material can sustain before it gives up. So you can know that.
Before it wears away.
You can know that, okay, maybe if it is 2,000 rubs, maybe this fabric is good to be worn on these conditions. Maybe for baby diapers, we can accept this. Maybe for this.
Okay.
Color matching.
This equipment is called color matching cabinet.
Color
matching. So one of the properties it does is right fastness. You know, when you hang like maybe clothes on sun, you see like some shoulders are fading.
Yes.
So that property we call it right fastness. Color fastness to right.
Okay.
So here you can maybe subject the fabric here for 12 hours and see the effect of it. And another thing, when you see these fabrics in this light, you cannot know if they are the same. But when you subject them to the same light, you can visually analyze.
You can see the difference.
All right.
Okay. Thank you.
For example, PPE, personal protective equipment for surgical workers, for example. So these are now prototypes.
Manufactured
ready
from
for
here.
Ready for commercialization.
Manufactured from here using local raw materials.
Yes.
I wanted that one to be clear. Okay, ladies and gentlemen, this is the Pan-African Pyramid Show. This is the Free Your Mind session, and we have visited the Namanve Industrial Park. This is Uganda Industrial Research Institute with Professor Dr. Kwesiga Charles. And we are actually looking at so many other things inside here, because Africa normally, they think that Africa does not do things. When you want a good cloth, you must go to America, you must go to US and UK. So here they are showing you that actually there are many things happening in Uganda that they are doing physically here, using the local materials here. But then sometimes we are not aware what's happening in our country. So this is just one of those that we need to know that some things are happening here in Uganda and Africa at large.
Here, again, demonstrating the world of possibilities.
The world of possibilities, that's a good one.
The pineapple fibers I talked about, that's the crown of a pineapple fruit. Can be turned into products like this, or products like that.
So what is this one, Professor?
That's packaging paper.
Yeah. From pineapple?
Yes. These are all from pineapple fibers. The crown of a pineapple fruit. They are always those green leaves. You can turn them into products.
And so, are these also coming from this, Professor? Are these products of this?
Yes.
These ones?
Yes.
These are masks for those who are not here. These are masks, face masks.
This is bagasse from sugarcane. And make paper like this. And make sanitary towels like this.
These are sanitary towels. Sanitary towels.
Yes.
For ladies.
Yes.
Now, I've been seeing.
Of course, the science behind it is a little more complex, but that's why we have developed medical textiles from Ugandan fibers, and the personnel involved include the principal investigator, Mr. Caesar Solomon. Participants include Dr. Kamgasha, Dr. Kampumuza,
Ms. Namiro Morin, Mr. Shaba Osbat, Ivory Brand. Hey. Yes.
Yeah. So this is UIRI what? So when you ask about for a demonstration, you see the science that goes into it. Can't just be, these guys do the background science. They prototype the products. Now it's up to we would now want to encourage private sector to come in and now take on the commercialization of these prototypes.
Hey.
Okay.
Okay, you have answered. We pass here.
This is a training in pneumatics and hydraulics.
Pneumatics and hydraulics. Break for us a little bit, Professor. For us who are not engineers. Pneumatics and I'm sure my
I don't know how you can break it.
my team wouldn't understand.
Okay, he can probably demonstrate an experiment here where you are training people on how automated bottling lines work. Bottling lines.
Okay.
Like you're filling bottles with Fanta and sealing them and labeling them on a, yeah.
Okay.
So, quickly.
Okay. Maybe let's begin with my brother. Your name? Owel.
Mechanical engineer.
You are a mechanical engineer.
Yes.
So what's this? When you bring me here, what am I looking at?
Now, pneumatics and hydraulics, if I can start with power. Power can be transmitted in three ways. We have mechanical transmission, that is through shafts, gears, chains. We also have electrical transmission, that is transmission through wires.
Okay.
So there is what we call
Like
fluid
Romania.
power. Yes. Then there is what we call fluid power.
Fluid power.
So fluid power, that is transmission of fluids in a confined space, what we call pneumatics and hydraulics.
Oh, that's what you call it. Okay.
So this side it is pneumatics, the other side it is hydraulics. When we are dealing with pneumatics, we are dealing with compressed air. Air. We trap air from the surroundings, then we use it to perform a useful work. This one is a setup for a pneumatic bottle filling and capping machine. This is a system used by most companies which pack soda, water, beer, whereby they feed a certain level in a bottle and put a cap. And if you realize, all the bottles, all the fruits within those bottles are at the same level.
At the same level.
So they use the system of pneumatics. Yes.
You have put on pneumatics now.
Yes. I'm first switching off on the compressor.
So here, this is the example of the bottles.
No, this system, as I have said, we trap air from the surroundings by the use of the compressor, and sometimes that air is not filtered. It's having some foreign particles. So this is called the FRL unit. It's a unit for filtering air, lubricating, and even measuring the amount of air to be used for the system.
Some air that you arrest from the air comes with some stones. So this one filters it.
Yes.
I want a very simple explanation so that people can understand.
When air is trapped from the surroundings, sometimes air is always containing small foreign particles.
Polluted.
That is dust, even a condensate. Because air, we always say air is always containing water. So when air reaches here, we have the first F, which is a filter. It filters to remove all the foreign particles within air. So when air proceeds to go to the regulator, not all air that comes from the compressor has to be used by the system.
You regulate.
The role of the regulator is to know the amount of air to be used by the system. Then we have the lubricator. The role of a lubricator is to lubricate the air in the form of a mist, such that the whole system is self-lubrication. So in pneumatics, we don't lubricate these valves. This air, when it is
the man wants to run away.
When it is lubricated by the lubricator, it lubricates the moving parts within the valves.
Then quickly demonstrate what each session does.
So now we have the lower limit and the upper limit. So the distance from the lower limit to the upper limit, that is the level of the fluid in the bottle. At the moment our piston reaches the upper limit, it tells the computer now, it tells the machine that you have reached the maximum. You stop there, it goes back. As it is going back, another bottle is coming. Remember, they've been moving in the system. So when it comes to this side, this one is for putting the cup.
This one?
Yeah, putting it.
Hey, so you're manufacturing these systems here in Uganda?
Yes.
The systems that these factories are using are manufactured here?
This is a training facility to show you how it works. Okay, if you want us to design a system for your particular...
You can do it here.
You can do that.
That's what I was looking at.
Okay.
You're not just training, but you can manufacture. Okay.
But anyway, so this is a demonstration of how bottling lines work.
Yes.
Filling to the desired level, corking the bottle, moving to the next stage, labeling it, and then packaging. Okay. So this is a facility where we can design any kind of electronic equipment and build it in this room. So quickly you can show where we start from. Okay. Using that computer, build a circuit, design a circuit, get it, where is the medium? Yeah, superimpose it on a medium, like in this case copper plate. And then when you're on the way to, what we are aiming to do is to eventually build the printed circuit board.
This one.
And then build, and then plant in components as you have designed. And once you have enough of these for what you are making, you take it to the electronic assembly and do the housing and all, and the product is out. So the radio that we have been prototyped was made here, and you're going to see it.
Okay.
You're going to see it there. So,
are you trying to manufacture a plane here?
The drone.
The drone?
Yes.
Hey, you mean you can make it?
Yes. Use them for security, for monitoring, for caching, getting footage, weapons, demonstration.
So you can manufacture a drone here?
Yes.
From here?
we are doing a prototype. This is the sequence of events. Let's take a radio, for example. The guys designed the circuit to make a radio. Once they have designed, they make printed circuit boards, where they plant the necessary components. After they have made the desired printed circuit boards, they then take them for assembly, where they meet the people who are, in this case, a carpenter shop that has created the casings. So the casings and the circuit boards, they are assembled in one piece, and the radio comes out.
So this is your very own?
This is our own, yes. So now, as we work towards industrial production, now they are making, how many are you making? 50? They are making 50 of these for test marketing.
Give me one to go with it and test.
And test marketing, this is similar in an orderly way.
I wanted to go with one and test it.
The test procedures are also our own design, okay? So then after you are satisfied with whatever feedback, then we can design a production line.
For this?
Yes.
Okay.
And that's where we anticipate make about 30 radios a day from this place.
Okay. So we shall not...
And then we shall expect that we shall have prepared ground for other entrepreneurs to come forth and start making.
So in the future, we don't need to import radios. You are going to be manufacturing from here.
You can make a new one, but we are showing you what can be done locally.
Toweebwa oba toganja alina ekyogo ekyambulula. These prepads will fall at regular intervals between 1 p.m. and 5 p.m. and again between 8 p.m.
Radio is clear. I wanted to find out whether it is clear, like the ones which are important.
Now is demonstrating the level at which we have reached the prototyping the drone. And to be in the same sequence, you prototype, then pilot, then from the pilot.
So who is the guy? Is the one building?
Bashir, yeah.
You are the one even who has made this?
Yes, we are.
We have a team.
Together on that.
So tell me, how long does it take you to come up with this?
This we go through a process of research and development.
Yes.
So depending on the challenges, we move through a timeline can go to 6 months, 9 months.
So for instance, how long has it taken you to reach this stage?
This one has taken around 8 months.
8 months.
8 months, yeah. And in a few weeks or a month, we shall be concluding, giving it a housing, then we go for outside testing.
This is
The remote.
the remote.
Yes.
When this is finished, Professor, how much do you think this can cost?
Come on now.
No, I'm just,
You can't
because-
determine that at this level until you have designed a production line, and therefore you can be very certain on what has cost you to make the product. Okay? And also to look at what the market will bear. Then you can start the pricing process. Okay? And then in terms of product cycle, it took a few weeks for them to design and make one prototype.
Of radio.
Yeah. It will take fewer weeks to make the pilot.
The pilot.
And once you have designed production facility, then you'll be generating so many per day.
These are all Ugandans doing this. Or you have some Chinese?
Have you seen a foreigner here?
No, I'm trying to wonder. Oh, these are done by Ugandans?
Uganda.
From where? Where do you come from?
I'm from Kayunga.
Kayunga here? You're Ugandan, you're doing this?
University?
Christian University.
Okay, so you're working on analog and digital?
Yeah, we were working on analog and digital, but we've moved to embedded systems. Okay. So as you can see, we have come up with small guidance like this one.
What's your name, lady?
Rachel.
Rachel,
Yes.
the African name, we are dealing with the Pan-Africanism. Mbeza.
Yeah.
That's your name.
Yeah, so we've come up with small prototypes. The sound detector is this one. So what happens is it shows the values here, and when the value changes, this motor runs. So the motor is meant to make noise and notify at the current moment. And then this joystick is used to navigate. So we've used these lights to show the navigation. So that's basically how it works so far.
Okay. So how sound detector, you have done motion detector?
Yeah, the motion detector is this one here.
Okay.
I wasn't necessarily part of the group, but I can try and explain what they have. So here they were supposed to detect the different distances. This is the motion, the ultrasonic
Sensor.
sensor. So what it does is it sends sound, and when it bounces back, it can tell you whether there's an object there, right? So basically, they also have it's an air. What is it? It's a gas detector. So this is what's supposed to show the values, right? If I'm not mistaken, it was supposed to be a buzz. This is a buzzer. It was supposed to be a buzzer when you come closer to the ultrasonic sensor.
It makes sense.
Yes.
It senses.
Yes, and then makes noise. And then this one was supposed to send values concerning the gas ratios onto the screen. Yes, I'm not too sure about the motor.
Simply put, the best way is to guard your home. Instead of having a sleeping guard, just put this thing, and when somebody crosses its path, the line of sight,
To make
the
nice.
light turns on.
Eh.
You know, if he's a clever thief, he'll run away. Okay. But you can also put a buzzer, you can do all kind of things. So they are
So this is a security gadget. This one.
it can serve as a security gadget, yes. But can be used for any
Different. Yeah.
Just showing you that we believe in demonstrating the practical aspects of the knowledge that they have picked up.
The fourth industrial revolution. I think you understand. I hope you understand the fourth industrial revolution, and this is the driver, isn't it?
Digitalization.
Okay, you understand it.
Yes, I mean, when we talk about artificial intelligence, these are machines they are acting like
a human being.
Yes, only faster and more efficient.
It's able to detect. So you come from Uganda Christian University.
Yes.
How many years does it take for you to learn and do this thing?
I think we do it in third year as an elective for computer science at least. So right now we're in second year, but because they're more of a practical school, they thought we've done the theory, so they brought us here to learn.
So you have come here at the institute, Uganda Industrial Institute, to do practical work.
Yes.
There you have been doing theory.
Yes.
Here you are doing practical.
Yes.
You are able to connect wires and even look at them and so on.
Yes, so the instructors have been teaching us how the different wires work and how to put it together. It has been really an interesting experience.
So how do you find this? Does this make a very big difference in your learning experience?
Actually, it does. I remember I was in digital circuits. I think that was last week. And he was explaining how we put together digital circuits. And I realized that it was part of what we were learning in computer organization and architecture. Before, I actually didn't understand the use of
Connection
course at school.
click.
But then when we got here, that's when I understood why we were learning it in class.
So I think these guys should never close.
Never.
Okay. Thank you. Very good.
When we are training, we don't waste a lot of steel, but so we use plastics for making products. And in a situation like this, with a computerized numerical control lathe, the engineer programs or designs the part, writes a program for it, brings the program and puts it in this computer, Then he can do a dry run to make sure that the sequence of operations is okay.
Is smooth.
Once they are comfortable with that, they put in a workpiece. This tool head here can run up to 4 different tools. And so once you mount them there, you stand on the machine and take a walk, and you come back and find your product complete. That's the different production method, and the other conventional ladies, where you have a machine operator running the thing until it finishes the production.
Yeah, you set it and leave.
These are different products we make. Including gears, designs like that, machined out of sheet metal. I'm sure you're familiar with Nike.
Very much.
Can design and machine the template for it. All kinds of intricate things. This is for extruding rubber insulating material, like for those windows. And this is
See this kawaya here? This wire is what cuts these machines.
that's through all this. And this.
That's my way.
Yeah. Example of so here we have made molds for people who are in the shoe business, so they can make shoe soles.
This is for the bottles they can
bottles,
guess.
yes. So that's the service industry.
Interesting. 3D printing.
That's plasma manufacturing.
Plasma manufacturing, what do you mean?
Making intricate designs like that.
Oh, these ones.
Yeah. Out of sheet metal to make something like that.
Interesting.
So, right.
This is tree of life.
Can make ornamental things like that.
This is interesting.
And this one, we call it it's just numerical, not computerized numerical control, but numerical control. In that you can pre-program the depth of cut, the length of cut. And then once you get started, it will move to the point according to those dimensions and stop there. And then an operator has to
manually move it.
Move it back to the starting point and repeat the process. Then for making big bore, you can use that machine.
Big bore.
A hole in the big disc. And for say surface milling a big facility, a big production product. Like for example, if I want to surface grind an engine block, then for if you have a big class or you have a big order or both, then you can deploy all these. Okay? But for precision machining, mass production, you use those on nearly.
Fantastic. Very good. Very good.
So this is a big board. So to do that, to cut that ring out,
Design that, yes.
you know, we
This
need
is
a
what it
machine like
does.
that.
So, Professor, where do you get these materials?
The metal dealers are not steel and tube, sorry. There are some special order. I wanted to set up our own foundry so we can make our own.
You can manufacture your own.
Yeah, but we have not gotten the money to do that.
Okay.
Now this one, it's a surface grinder.
Surface
But
grinder.
the difference, you see, when they are doing that process, they are clamping the piece they are working on so that it is in one place and they machine it. Here, once you turn it on, it magnetizes this table, and the magnet is what holds the workpiece. And then you can do the machining.
So this is a magnet.
This table gets magnetized. This table. This is a piece of metal which will be held by the magnetism of this table so that you can do the milling, the surface grinding. For machine maintenance, for example, you can have a small operation, a small piece of machine zonks out or gets malfunction, then it's downtime until a Chinese or an Indian comes to repair. So I decided we need a facility where we can train and maintain how the maintenance of machinery, repair, and even calibration. I had a situation at Nakawa where one piece of equipment in the chemistry laboratory, every time it developed a hiccup, I would call Cairo for somebody to come and then take a diagnostic and then go back and come back. And after 4 trips,
And that's a lot of money.
we have a solution. I said, no, this is not sustainable. Then, so one time I was at Bank of Africa and I saw a teller who was very uncharacteristic of Ugandan customer service, doing very efficient work. I said, what's your background? He said, I'm an engineer. I said, no, you are the engineer doing the job of the tail? What's wrong with this picture? So I came back and I said, here I am calling Cairo to repair my equipment, and the Ugandan trained engineer is working as a bank teller.
Where?
Here in Kampala. So I said, okay. That's when I set up something I called the experimentation unit. Got some local trained engineers and software designers and so on. I said, commit your book knowledge to practical application. And they started work, and before long, they made a contraption called ECGF that won first prize in Oville, California. This contraption, electronic piece of equipment that would monitor and regulate intravenous medication. You pre-program the dosage, and thing goes to work to regulate the flow rate of the medicine.
So this is the guy whom you got from the bank?
I learned from that that we must develop, redirect our technically trained people. And so I think 5 of them came and started doing wonderful things. Unfortunately, I've since lost the majority of them. One of them was snagged by Rolls Royce in UK.
Hey,
I trained him here in Nakawa.
you trained some guy here in
I
Nakawa,
worked for
and Rolls Royce took him.
What happened was I encouraged him to do master's degree online. And he was doing it from here. And then when he came to the last part of
His training.
he had to go to defend his papers in UK. So while there, he called me. He said, in 2 weeks I'll be home. A week later, I said, sorry, Rolls Royce has given me an opportunity I can't refuse.
Rolls Royce. And now this is the whole interest of this kind of tour we are doing here, to show Ugandans that we actually have what it takes, and even some people are doing it. But then some people think this is so complicated. It needs rocket science. Yet actually you are doing it.
So
these are the things they have so far fabricated here. Is what?
this sheller. Put in cob. This cob and
Grinds.
Not grinding.
It removes. Yeah. From the. Yes.
Moving the kernels from the cob.
Yes.
The grinders. These are for making pellets for animal feeds. Settling tanks, even electronic switch control. So this is the textile center. These are uniforms here.
So
How long does the company come and stay?
No, they don't come stay. No, if let's take the military, for example. They have an order for uniform. Oh, in Terry School, I just doing Terry School uniform. So they work it out with us. We get manpower. We pay them per agreed fee. We pay for the raw materials, and we fill the order.
That's what used to be done anyway, you know which.
They made my uniform, I remember.
Because we used to never ask when you get to the uniform.
Yeah, so by then, what I'm encouraging are private sector people to take use of this facility as they develop their own capacity out there. So recently, there has been a company called anyway, there's a company that was engaged in making these reusable sanitary pads, and they were making them here. In the near future, we're starting a big class for different groups from different parts of Uganda to become proficient in tailoring, and they go back and so I have a team in Shema that trained here, I have a team in UIRI that trained here, I have a team in Tororo, and so on.
Okay.
So this is our woodworking facility.
Woodworking facility.
So you can see something familiar. They are making
Radio.
casings for the radio.
The casings for the radios are made from here.
Yeah.
Hey.
And they're also involved in with the biomedical engineers. They're building carrying cases for premature babies. Are you okay? Somebody is using discarded bamboo to make furniture.
I was fearing to sit on it. It's so.
You fear nothing, man. Now another thing.
These are bamboos.
Yeah.
Another thing.
Another thing about this facility. So there is zero waste.
Hey,
You can compact it into briquettes.
this what I see is there is nothing that will drop on the floor.
ground, no.
They are sucked.
That's right.
And then you use it for what?
Making soft boards or making briquettes, anything you can. You can compact it into anything you want. Okay, so there is zero waste. Yeah.
So here, from here, where are they?
They're going to those pipes. That big pipe takes it. Is a facility out there. It's a holding bin. That's where stuff gets stored. So you don't abuse the environment like those guys are doing. those steel and tube. They are donating too much ash from their obsolete machinery. Okay. So all these wooden products have been made here. Unit for wood. This is for soap making. When you have made a slab of soap and you want to cut into even bags, this is for labeling soap. When you pass through it here, it makes letters. Soap.
So this is the bar of soap. Each one of these represents a bar. Okay.
So here we have the weaving studio.
It's called a studio.
They are weaving these products.
Hey.
From kikoris to tablecloths.
They're doing it from here.
Important thing is this loom was made here by our own carpenters. This is automated weaving. That's manual.
These are as a result of this one. Taken us through the positives of all this project. Can we end up with a few challenges you have faced since you started this project?
We are not ready to use the expression "I don't know." So some of our technicians, if they don't want to admit that
they don't know,
sometimes they can lead into, or they even make the training process very complicated. Somebody keeps saying, "Oh yeah,
when you say, okay, do this,
right.
Start making the radio."
So we have that challenge, but over time, now the coming here, you saw what kind of situation we're in.
The road infrastructure, Professor, the jam.
That's right. So those are systemic problems that make it hard for us to move at the pace we would like.
Because I honestly believe that this is an industrial park. An industrial park, the first thing they would look at is the road infrastructure. Because, you're dealing with heavy machinery. Everything that is coming here is heavy machinery. So I thought that would be
even light machinery. My challenge is the machines you saw in there.
Yeah,
some of them are extremely sensitive to elements.
Bringing them here, the road.
No, those that are already here, but you have all that debris, all that dust, mud. Then we have ash.
Ash is coming from where, Professor?
From some of the neighboring facilities.
Yeah.
Because we have let them come in with obsolete equipment. So they are abusing
The environment.
environment, and we become victims.
Yeah. Okay, maybe my last question, Professor. You have a very good project, you have implemented, everything's going. But from here, do you have future plans beyond this, beyond what you have seen so far? Are there some future plans that you have in your head, and there might be some kind of infrastructure in terms of funding or support is hindering those future plans that you have? I mean, you could be having one building, but your future plan is two buildings, but then you don't have the capacity. Do you have some future plans from here beyond what we've seen? What are you looking at?
We are still struggling with implementing this phase. But the original future plan was to make this a successful model and then replicate it regionally.
Oh, you want this to be regional?
Yeah, so we can go to other regions and do similar things. Maybe focusing on the economic activity that is prevalent in a given region. That was the original plan. But when you start getting challenges like funding for the first phase, I've always suggested that if I could get the full funding I need for 2 years, after that I would not need government support.
I want to thank you so much for accepting our invitation and our interview. And maybe if I would ask you, how much has this helped in terms of dealing with this feeling that Africa cannot do something for themselves? What have you solved with all this in terms of that context?
When you see products being made by these guys, and you know at the level where they came in, isn't that a gratifying evidence that something right is happening? When somebody starts with a contraption like this
one,
this was the radio that they first made before you saw the ones they are now making, and the fellow, his first effort was this radio. Okay.
That was the radio.
That was the radio this young man made. And through guidance and good utilization of the facilities and his own change of mindset,
that's the radio we have to make.
And now we are in the process of putting together a production line to make these radios.
You had told me earlier you would be making 50 per day. 50 or 30 per day. Yeah, I think this is a very good journey for Africa, for Uganda, to see that we are doing some of these things now here. Africans have been into this mindset that we have to be helped all the time and we have to import. You export materials, then we import finished products. Here, Professor Charles Kwesiga is actually showing you that even from the pineapple that you eat from your home, don't throw that leftover that you see. You called it what, Professor? That
the crown
of the pineapple. He can manufacture.
Leaves,
yes, those leaves. He can manufacture something for you, and you use it here. He has actually demonstrated it. So we've seen a lot of things happening here. We have seen that they can manufacture clothes here. We have seen them, and so the notion that Africa will always be dependent to the Western powers. Some of the people here in Uganda and Africa are actually demystifying that by practically doing things that even the Western person, the Western man could be actually loving to buy from Africa. So the mindset is that, no, it is not true that we cannot do something. It is actually very true that everything they are using there as raw materials are here in Uganda, and given the opportunity, we can actually manufacture even much better things than maybe what we import from the rest of the world. This is the Pan-African Pyramid Show Free Your Mind lecture session, and I've been hosting Professor Charles Kwesiga, the Executive Director of Uganda Industrial Research Institute. They have two campuses. There is one at Nakawa, but this one is at Namamve Industrial Park. And my name is Andrew Irumba Katusabe, your speaker. I give thanks to my production team that I moved with here, and of course, Professor Kwesiga for allowing us to partake of his knowledge, and really would like to appreciate Professor. Thank you so much.
Thank you, sir. Thank you.
Thank you.
Thank you. All right.